Welcome and hello. This is a video exercise using the FHWA hydraulic toolbox and specifically the curb and gutter calculator. I'm titling this exercise Sag Inlets and Clogging because we're going to be using a sag inlet with a range of clogging percentage. And what we're going to be finding here is the grate depth and the spread width for that sag inlet for a clogging range of 0 up to 80%. So you see in this slide here, we have a number of different parameters that are given for our curb and gutter analysis. We're using a combination inlet with some data for the grate and the curb inlet. There's two different parts of the inlet with an equal length. The length happens to be 4 feet, right? And then over on the left here, we have the slope, the cross pavement slope, Manning's N, flow rate, and gutter width. All right, so what I'm going to do is bring up the hydraulic toolbox right here. I've already got projects started. So what I'm going to do is right click and open up a new curb and gutter analysis, and then double click to open up the calculator. Now, some of these parameters are not really used, like a longitudinal slope on a road. Since we're going to be using inlet in sag, I don't think this term is even used. I'll just type in 1%, but we can do a sensitivity analysis using this calculator later if we're interested to know for sure. All right, so this is important. The cross slope of the pavement, that was given to us as 3%, so 0.03. We were also given the Manning's roughness value, which is 0.016. I believe this term is also insensitive to our results, but we'll check that out later. The gutter width is 2 feet, so that is correct. That's the default. The design flow rate we were given is 5.3 CFS. And then I'm going to click on Compute Unknown. That'll give us the width of spread as well as some other hydraulic parameters. All right, so that is the gutter data. And then next over on the right side is the inlet data. So inlet and sag, we've already selected them, which basically means we have a sag in the curb, a vertical curve. For the percent clogging, I'm going to start it at 0, but we were told that it's going to range from 0 up to 80%, which would just be an 80 right there. So we'll come back to this later, but we'll start it at 0. And then for the inlet types, our options are grate, curb opening, slotted drain, sweeper, and equal length combo. Now we have data for a combo, a grate and curb opening. So that's going to be an equal length combo. So when I select equal length combo, now we have parameter data for both the grate and the curb opening. So the grate inlet will be, oh wait, hold on a second. So the grate type, yeah, it's this first one here, P1 and 7/8 inches separation between adjacent bars. Width right here is going to be 2x4. That was also given information. And then since it's equal length, the length of the inlet is also 4 feet. That's automatic. The exact same value that I type in here. So 2x4. And then the curb opening height, we were given this as 3.9 inches. And local depression, we were not given a local depression, so we're just going to assume 0. All right, so with all of these numbers typed in, I'm going to click on this compute inlet data. And then down below here are my results. We have the perimeter, the effective perimeter, area, effective area, depth at center of grate. This is one of the parameters that we're interested in, as well as the computed width of the spread at the sag. So these two terms right here, 0.365 feet and 13.178 feet are the two terms that we're interested in for this particular flow rate at this particular percent of clogging. So what I'm going to do is keep track of my results. I have a spreadsheet started here. So for the depth at the center of the grate, that's 0.365. I'll type that in here. And then the next column over is going to be the spread width. That's 13.178. 178. Okay. And I'm just going to repeat that process for the other clogging percentages on a 10% step. So this is just sort of an arbitrary step that I came up with. I felt 10% would be enough to give us a good amount of data to see the relationship between the percent clogging versus grate depth and spread width. So back to the calculator, I'll type in 10%, click on compute inlet data, and then as before, I'll look at my results of 0.392 and 14.065. It looks like the depth and the spread width have both slightly increased, so that's good to know. 0.392 and 14.065. Okay, Next up is 20%. So we'll type in 20, click on compute inlet data. This is still sticking with all the same flow rate and gutter geometry. And then here are our results: 0.424, 424, and 15.132 on the spread width. Okay, next is 30%. So let's go 30%, compute 0.463 and 16.447. Okay, so I'm going to do that for the rest of the percentages here off camera. At 80%, this is the last one. It's 1.068 feet, so over a foot now, ponded up as the depth, and then 36.610. Okay, so we finished up our data collection for this particular grate size. As you may have noticed, I've got a second grate size because it just wasn't enough data for me for one exercise. But as the percent clogging is increasing, we see the grate depth increasing and the spread width increasing, which makes sense because there's going to be less drainage through a more clogged grate. Out of curiosity, I just doubled the grate size by doubling the length. The width is still 2 foot, but instead of 2x4, now we have 2x8. I know this wasn't in the original problem statement, but I'm going to collect the data anyway, and it really shouldn't be too involved. So in fact, let me go ahead and just hide these two columns while I'm doing the data collection. Okay, let's pull that off to the side now. In the calculator, what I want to do is just change the grate length from 4 feet up to 8 feet. I'm going to reset the percent clogging down to 0 and repeat that same data collection process. So I'll click on compute inlet data. Now the depth at the center of the grate starts at 0.279, and then the computed width of spread at the sag is 10.294. Let's get that recorded over here, 0.279 and 10.294. All right. Repeating with 10% clogging. So that's 10%. Compute 0.299 is right there, and then 10.970. Okay. So again, I'm going to repeat all of these calculations off camera, and boom, here are the numbers. So I'm going to unhide the data for the 2x4 grate, unhide. And now we can compare the grate depths and the spread widths between a 2x4 grate size and a 2x8 grate size for the different clogging percentages. Okay, I've done that in this screen right here. I've got a couple plots. What you're seeing on the left plot is the width of spread and how that increases with the percent clogging. So my independent variable here along the horizontal axis is percent clogging, and then the width of spread ranges from about 10 feet up to about 35, 36 feet. The two different series of data, the orange is the 2x8, and then the black or the navy blue here is the 2x4 inlet grate, or the combination inlet grate. What we can derive from this is clearly the larger the inlet size, then the less the width spread, which makes sense. And then as the clogging increases, the width spread also increases. I think is pretty much intuitive, but to actually see the numbers here can help planners decide how many inlet grates do we need if we know that our design storm will generate 5.3 CFS at this particular location. And say, for instance, the clogging will never be more than 50%, and the largest allowable width of spread is, say, 15 feet, in which case 2x4 wouldn't cut it, but 2x8 inlet size would be sufficient. So that's basically why we would create a chart like this to provide a client. All right, now width of spread is not the particular parameter of interest, but depth at the center of the grate is. We could repeat this same plot, but using the depth as our dependent variable. Again, across the bottom, we have our percent clog from 0 up to 80%. We could have done 90%. 100% probably would have yielded an error message of some sort, but as you can see, it looks like for both of these curves, the slope is increasing as that percent clogged also increases. The depth, of course, is lower at the same percent clogged for the 2x8 size inlet compared to the 2x4 size inlet, and the depth increases as the percent clogged increases. All right. As for the specific numbers, it kind of depends on what is required for your design. For the sake of this exercise, we were just using the calculator to get a general understanding of the trends between these different variables. All right, well, that's it for this exercise. What we did was use the curb and gutter analysis calculator within the FHWA hydraulic toolbox to analyze the relationship between percent clogging, depth at center of grate, and computed width of the spread at sag.